Hi everyone, and welcome to our video on infinite limits. So an infinite limit occurs when a function increases or decreases without bound near a point. So that means it's either going up or down at a point. We use the infinity symbol to indicate a limit grows arbitrarily large. Often vertical asymptotes are involved. So like in our picture that we're about to do, those dashed lines are called vertical asymptotes. And we can see the graph is headed up toward this one, and then on this other vertical asymptote, it's kind of split. Okay, anyway, so where this occurs is when we have our limits, when we plug in the value, gives us some constant over 0. Okay, so then we know it's either going to be positive infinity or a negative infinity as an answer. All right, so that's what we want to focus on. Okay, and then recall, like in a bunch of the previous problems that we did, so that are now erased because sometimes this ink does not hold well and it will freeze. When you have 0 over 0, which occurred in a lot of these problems, 1 through 6 it did. So 1 through 6, it occurred 0 over 0. We usually use algebra techniques to solve it. And again, we could always use a graph or calculator when allowed. All right, so anyway, so let's break down these problems. So in example 1, we have this picture. It says use the graph of f of x. So we're assuming this is f of x that's graphed to find the following limits. Okay, so as the limit of x goes to -3 from the left of f of x, we want to see, well, as x goes to -3 from the left. Okay, so let's do this one from the left. We could see, here's from the left of -3, and we can see it looks like it's just going up. It's following the asymptote toward up forever. So it's going up forever. If it's going up forever, that means it's going toward positive infinity. Okay, whereas, so we're going, these three are the ones that involve -3. We'll keep it together. Okay, so -3 from the right. So that was number 1. We'll mark it. From the right, so here's -3 on our x coordinates, and then from the right is somewhere over here, but then we follow the graph, and we can see, oh, it looks like as we get very close to -3 from the right, it's going down forever. So going down forever would be negative infinity. Okay, so y is going down to negative infinity. And then our third one, well, this just depends on the rule that we'll use. We just have to compare these two answers. These two answers are different. One's positive, one's negative. So that means this one does not exist. So remember, these have to be a match for this to have an answer. Okay, so there's that. And then let's see, let's group these. They are all involve 1. Okay, so as x goes to 1 from the left, so here's our x coordinate 1, and from the left, it looks like it's going up forever. So that means this is going to positive infinity. So our y coordinate is going up forever. From the right of x equals 1, that's somewhere over here, and then starting to go up. Well, going up forever, again, is infinity. And then our number 6, well, all we have to do is look at our previous answers. As x goes to 1, this means from both left and right side. If these two answers are the same, then we write that answer. Okay, and they are the same this time, so that means we have our answer. There it is. Okay, so to do problems where they don't give us a graph, well, we still follow the same old steps that we want to. So we still plug 3 in. So notice all these are the same function. And if I plug 3 in exactly, I would have, so my scratch work down here, if I plug 3 in, I'd have 9 plus 3 minus 6 over 3 minus 3. Well, this is 12 minus 6 is 6 over 0. So here we have a constant over 0. So that means let's just go ahead and graph it and see what it looks like. Okay, so we'll use our calculator. Okay, so it's from a previous problem. Let me go ahead and delete it. Okay, so all I'm going to do is plug this in. Remember to use the implied parentheses. Okay, so I've got parenthesis x squared plus x minus 6 parenthesis divided by parenthesis x minus 3. Okay, so there we go. Okay, and then now, well, it kind of looks like I need to zoom out a little bit. We can kind of see where it is. Let's go ahead. I'm going to do x equals 3, and that's going to show where my asymptote is. Let me go ahead and do the setting button so I can change it into a dash line. Done. So that setting button, you can just change some of the value or the layout. And we can see, okay, so as it gets close to 3, and here we can see 3, 1, 2, 3. So whenever you have that constant, so like 6 over 0 there, we know that there's an asymptote, and then from there we can answer it. Well, looking at this from the right, it sure looks like our graph is going up to infinity. From the left, it sure looks like it's going down to infinity. And that's all we need. Okay, so from the right, and just make sure we answer them in the correct spot. So I said from the right, it's going up to infinity. From the left, it was going down to infinity. Here's our sketch. Okay, so just to reference it, it looks something like that and that. Okay, so just a very, very, very quick sketch. Okay, so it's something like this, and then something like that. Okay, either way, so I just wanted to get that just to really make sure I didn't write the answers wrong. So from the left, down, yep. From the right, it's going up. Okay, and then that way we can answer this one. This one is a does not exist because these two answers were not the same. Okay, so pretty nice, right? So that analytically means, well, to analyze some form of it, like our graph, and that's all we had to do. Okay, so moving on. Let's see these others. Okay, so notice 2a, 2b, 2c, they're all the same function, and just from the left, so that's a typo, so because it's the same problem then. Let's make that a little plus. That's what it should have been. Okay, so, and I should fix that before the video anyway. Okay, but just in case I forgot, so negative, little plus, and then just from as it goes to -6. Well, again, just quickly plug in the 6 value. So I'm going to put that scratch work right here. So if I plug, -6, if I plug -6 in, I'd have -6 minus 10 is -16. And then down below, -6 squared is 36. And then -6 times 12 would be minus 72. And then plus 36, yep, that is 0. Okay, so I have a constant over 0 again, which means let's just go to our graph. Okay, so let's get our graph going. Okay, so let's go ahead and clear those out. And I'm just going to plot it in. Again, remember that they changed the letters on us in these problems, but the program wants x. So just change these to x's so we can get our graph. So we have x minus 10, parenthesis divided by, parenthesis, x squared. Oops, I did the wrong parenthesis. There we go. X squared plus 12x plus 36. Okay, so that's what that looks like. And then whenever you have the constant divided by 0, we know that at the -6, so I'm going to do x equals -6 just to show the asymptote. And notice it is x equals -6. Okay, so you have to put that. If you just leave it as -6, we don't see it anymore. Okay, so it's gone. So we want that x equals. So vertical lines have x equals as the vertical line notation, and then I guess just to make it dashed, let's do that. There we go. Okay, so we can see there's the 6, and I'm just zooming in to really verify that the graph is headed toward that asymptote. Yep. And then we can see, from both the left and from the right, they're both going down. So that means it's headed toward -infinity. Again, I'm just using the mouse roller to scroll. Okay, so it goes down to -infinity for both. So from the left, -infinity. From the right, -infinity. Since these two are the same, our answer for this one is also -infinity. Okay, so there was our -6. X equals -6 is the vertical asymptote. Okay, so in vertical asymptotes are always x equals a number. X equals a number is a vertical asymptote. Okay, so that was that, and I'm just getting our quick sketch, and it looks something like this, where they both went down forever. So negative infinity, negative infinity, negative infinity. Okay, so that's how. So these ones I think are nicer than some of the ones we've done before. They're pretty quick sketches once you plug it in. All right, so one other thing is they might want us to find vertical asymptotes. So find all vertical asymptotes x equals a of the following functions. For each value of a, determine the limit for all of them. Okay, so it's kind of a little bit in reverse. So vertical asymptotes will occur. Let's add this rule. So it appeared in our domain problems from a while ago. So vertical asymptotes occur where the denominator equals 0, as long as there's no common factor in the numerator. As long as there is no common factor in the numerator. So if there is a common factor in the numerator, then you would get the 0 over 0 case, and we would have a different style problem. Okay, so like let me scroll. So again, I erased the ink, but on these problems, we had 0 over 0, and we look to just cancel something out. Okay, so 0 over 0, you usually use algebra. So anyway, so if I had 0 over 0, I wouldn't have vertical asymptotes. On this, my factor up top is 4, so that's not going to be in common with anything. Okay, so where my vertical asymptotes occur, I'm going to write VA dot 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 is when the denominator equals 0. So let's set our denominator, x cubed minus 7x equals 0. And then I want to solve this. Well, to solve is to factor. So x can factor out of both terms here. And then I'm left with x squared minus 7 equals 0. And then now I can solve each of these. I can split each of these equal to 0. So x equals 0 and x squared minus 7 equals 0. Well, x equals 0 is already solved for. And then this one I could add 7 over. X squared equals 7. And then I could square root both sides. Now remember, if you square root, to do plus minus on the numerical portion. So we get x equals plus minus square root of 7, which is really two answers, the positive square root of 7 and the negative square root of 7. Okay, so we have these are where the vertical asymptotes are. Okay, so that is if they just want us to find it. Either the other way we could do this, so the square roots are important in case it's some weird number like they are. But we could also, again, use our calculator. Let's graph it. Okay, I'm going to delete all again. Okay, and then let's plug that in. So I have 4. So 4 divided by x cubed minus 7x. And then with this, we could start to see those vertical asymptotes. Okay, so we have, let's go ahead and plug. So here we can see that there's 3, but our math also shows them. So let's go ahead and get them all in. So we have x equals 0. We have x equals square root of 7. And we have x equals negative square root of 7. Okay, so there they all are. And then let me just change them to dash lines just because I want to. There we go, done. And you can even change the colors. Okay, so if you want to. Okay, so anyway, so there we go. All right, so we can see now all the nice picture, and finding these. So the square root ones are a little tougher to have seen. That's why it's nice to still be able to solve this equation. Notice the 0 one was no big deal, but we can still see that okay now. Okay, and then now it looks like we can find all of them with no big deal. They're all pretty easy to find just looking at it. Okay, so we found all. So for each value of a, so technically these are the a values that they want us to plug in. So now what we have, so let's show the notation that they want. So that was the vertical asymptote portion. And then now we're doing this limit, the 3 limits. Okay, so they want us to find the limit as x goes to, let's just go in the order that we found them, 0 from the left. And then they want us to do the limit. Let's just leave a little space. There we go. The limit as x goes to 0 from the right. And then the limit as x goes to 0. Okay, and then that's the picture. That's our graph where we're looking at 0. Okay, so here's our 0 portion. Well, it looks like from the left, it's going up to infinity. From the right of 0, it's going down to infinity. So left of 0, that's this first one, up to infinity. Right of 0, down to infinity. Because these are different, this is a does not exist. Okay, so that's that. And then our other two, so if you see those, you can write them in real quick and be done with it. Let's go ahead and finalize it. Okay, so let's do the positive square root of 7 from the left. And then we have, so I'm just setting it all up. The limit as x goes to positive square root of 7 from the right of our function there. And then the limit as x goes to square root of 7 on its own, just like that. Okay, and then again, I'm just going to quickly look at our picture. Square root of 7, that's where the green one is. Okay, so from the left, we can see it's going down. From the right, it's going up. So from the left, negative infinity. From the right, it's going up to a positive infinity. These are different, so that means it does not exist. Okay, so from the left, that's that. Okay, and then one more. The negative square root of 7 one we can see right there, but let's write it in and make it all formal. So the limit as x goes to negative square root of 7 from the left. The limit as x goes to negative square root of 7 from the right. And the limit as x goes to negative square root of 7 by itself, just like that. There we go. And then now we'll again, just quick picture. Looks like from the left, it's going downward. From the right, it's going upward. So from the left is negative infinity. From the right is positive infinity. And then those two didn't match, so it's a does not exist again. Okay, so there's our cases with infinity. So this is where infinity answers come from. When the graph is going up, just like these. So when the graph is going up forever, and you can zoom out as much as you want, it's still going to go up forever in those places. It's still going to go down forever in those places. And that's where those infinities come from. Okay, so anyway, so that's it. So, and these are like y coordinates, so they're not exactly y coordinates anymore because infinity is not really a number. It's just letting us know it's growing forever. It's going to go up forever or going to go down forever. Okay, but that's it. So if you do have any other questions, please let me know. Otherwise, thank you for watching, and I'll see you next time.